Hi, Earth and Planetary Sciences. I'm Laura Gardner, and I'm a second-year graduate student in the department. At the end of winter quarter last year, I secured an advisor, Steve Jacobson. We had just enough time to establish my primary project, and then the world shut down. So since spring, I've been preparing to embark on this project. This project will investigate mineral inclusions in 41 super deep diamonds from Juína, Brazil, much like the one shown here. And the first step in this project is to get them to Argonne National Laboratory's Advanced Photon Source, or APS, to perform microtomography on them. This will enable me to locate individual mineral inclusions and assess their integrity. Once that's done, I can perform single crystal X-ray diffraction on each mineral inclusion to determine what mineral it is exactly. And the second part will also occur at APS. This project ultimately is about water in the deep earth. When super deep diamonds form at hundreds to maybe more than 1,000 kilometers below Earth's surface, they often trap bits of surrounding mantle in them, and that's what these mineral inclusions are. If I'm lucky enough to find hydrous silicates, like this hydrous ringwoodite, within these mineral inclusions, then I can study the water in the deep earth. One thing I can do is use nanosims to probe the deuterium to hydrogen ratio of water within these hydrous silicates. And this will ultimately help us understand where water in the deep earth is coming from. So far for this project, I've submitted a proposal to APS, and I've been allotted beam time there, albeit remote beam time, in the fall of this year. I also established my second project this summer, and it's going to focus on the kinetics of the back transformation of ringwoodite to olivine. Olivine is an extremely prevalent mineral in the mantle, and at sufficient temperature and pressure, it transforms into the high pressure phases wadsleyite and ringwoodite. In a rising mantle plume with reduced temperature and pressure, these high pressure phases can transform back into olivine, but how and when exactly this occurs could be better understood, and that's what this project is going to focus on. Each one of these mineral phases has different physical properties, and so they affect mantle dynamics differently. So ultimately, this project will hopefully provide some insight into mantle dynamics. And so far for this project, I've just begun a review of the literature and textbooks on the subject.